Okay. Now, this is the start video for the past papers. That is 2001 is good to start. These are coming even today in exams. So we will go through the first question. It is the first one is true or false about liquid dosage forms. So liquid dosage forms include the suspensions, solutions, emulsions, etc. So first question is, when reconstituted, cloxacillin sodium powder forms a solution. That is false because cloxacillin sodium is soluble. That is true. But large quantities in a limited volume of liquid. So that means not no sufficient liquid water to dissolve the whole thing. So it is as a suspension, not as a solution. Sodium salt of cloxacillin is more soluble in water than cloxacillin. But however, the concentration is too high to keep the sodium solution, keep everything in the solution. So we'll go to the second one. B. Benzyl benzoate application is a colloidal solution. Right? Now, benzyl benzoate, that is false. Benzyl benzoate is a lotion. It is not a colloidal solution. First thing, the concentration of benzyl benzoate is 26% in the lotion. That is benzyl benzoate. 26 grams is in 100 ml of the lotion. You can write down if you like the points. So it is used as an external application for scabies. Now let's see now we can see solutions, we can see suspensions. Obviously, we know suspensions are not transparent. You can't see through it. Solutions, you can see through the solution. The particle size is the important thing. The particle size of the suspension is more than 10 to the power minus 5 meters. So 10 to the power 7 to 10 to the power 5, 10 to the power minus 7 up to 10 to the power minus 5 meters are included in the colloidal part. They are colloidal solutions, or also called colloidal suspensions, because it is in between the solution and the suspension. So in solutions, you get less than 10 to the power minus 7 particles. They are very, very minute. So this is the picture gives you the idea. Particle size is less than 10 to the power minus 7 in the solution. So in colloidal solution, the particle size is between 10 to the power minus 7 and 10 to the power minus 5. Here it is centimeters, but actually it is meters. So here it is 10 to the power more than 10 to the power minus meter of a meter. So sometimes they ask about this Tyndall effect. Tyndall effect is when you send the light through a solution, you can't see the light passing through the solution. The light will go through the solution, but you can't see the beam there, light beam. But in say colloidal solution, you can see the light paths go through it. Light path is going through it. And say, if you think about suspension, the light will never pass through it. So this is called Tyndall effect. You can see the light beam inside the solution. Then go to this next part, gum acacia. Gum acacia is a suspending agent, sometimes used as an emulsifying agent. Gum acacia forms a colloidal solution in water. That is not a colloidal solution. Gum acacia forms a very viscous solution. It dissolves in 2 grams in 1 milliliter of water. 2 grams of gum acacia can be dissolved in 1 milliliter of water. So it is a very thick solution. So that answer is false. So go to D. As a liquid dosage form, magnesium trisilicate forms suspension. That is true. In liquid forms, magnesium trisilicate is a suspending agent. Magnesium trisilicate suspends in the solution without the help of the suspending agent. That is true. This is a magnesium silicate suspension. So magnesium trisilicate forms an insoluble and diffusible suspension. Insoluble and diffusible means you can take a pourable dose without help of another suspending agent. If it is something like calcium carbonate, you have to add a suspending agent to keep the insoluble particles in the suspension. Chalk, sulfonamide, all sulfur drugs, they are heavy. You need a suspending agent if you are going to give it to a patient to keep that in the suspending situation. Otherwise, it will go down to the bottom. Can't take a portable dose. Vitamin E, palmitate, forms a solution in sesame oil. Vitamin A, D, E, and K are fat-soluble solutions. They are fat-soluble vitamins. These fat-soluble vitamins are normally, if it is given in a liquid form, it gives in a oil, dissolved in oil. It is water insoluble. So, E answer is true. I have put it there. Answer is true. 2, question 2. True or false? 1 teaspoonful equals, this is one. Everybody knows 1 teaspoon is 5 ml. 1 pint equals to 500 milliliters. That is false. It is 473 milliliters. That is in the US. British system, it is 568. They are close, but 2 different definitions they use in those 2 countries. Normally, we mostly follow the British system. Quarter grain equals to 30 milliliters. This is actually, grain is a weight, so it is obviously false. 1 milligram is 64 grains. You can omit the last grade. So, one fluid ounce equals to 60 milliliters. That is false. It is 30 ml. Fluid ounce is 30 ml. Actually, it is 29.67, but you take it as 30 ml. So E 100 microliters equal to 1 milliliter. So it is false because 1000 microliters equal to 1 milliliter. 1000 1 milliliter. Question number 3. So true or false? Now crystal violet is a different compound from gentian violet. That is false. Both are given to the same chemical. Two names for the same chemical, crystal violet and gentian violet, are the two names given to the same chemical. Then the niacin and nicotinamide. See the structure. Niacin and nicotinamide. This is niacin. This is niacin. So one is nicotinamide. This is amide part here. This is niacin. So obviously two different compounds. So the answer should be false. Niacin is between B3. Okay, go to question C. Glauber salt. Glauber salt is salt that we call it Sahindalunu. In Sinhala, sodium sulfate. That is sodium sulfate. That is true. D. Glucose and dextrose are the same compound. That is true. Glucose has two different optical isomers, D and L. So D isomers and L isomers are there. You can see when the label also glucose D. Glucose D is that called dextrose. Glucose D is called dextrose because it is dextra rotatory. That is deviating the plane polarized light to right direction. That is optical isomerism. You all learned it in A level. Calamine is a form of ferric oxide. Now, calamine, you can see it is over the counter preparation. So, calamine lotion. Calamine is not pure ferric oxide. When it is mixed with zinc oxide, the mixture is given the name as calamine. You have to remember these ingredients. Normally they ask this, expect you to remember the amount of ingredients. Calamine BP is 15%, that is zinc oxide. Glycerol, that the entire thing. Then zinc oxide 5%, bentonite, sodium citrate, phenol and 0.42 phenol. They use phenol is a preservative. Sodium citrate is a buffer. Bentonite is the suspending agent. Glycerol is a thickening agent to keep the lotion attached to the skin. Ferric oxide is given to give that pink color, coloring agent. Ferric oxide is the coloring agent. Some functions of the practice of pharmacy include the following: true or false. Now, Question: identification of drugs, substances, true. Preparation of medicines, true. Performing inspections of retail pharmacies, that is true. Prescribing any of the available medicines to patients. Pharmacists cannot prescribe anything in the pharmacy. And dispensing of veterinary prescription, that is true. So C and D are false. Number 5. True or false about liquid oral dosage forms? They are less readily available for absorption compared to solid dosage forms. Obviously, false, because liquid dosage forms are easy to absorb. If you take a tablet, the tablet has to absorb water, then disintegrate, break into pieces, then go to the solution, that is called dissolution. Takes time. So compared to liquid forms, solid dosage forms take more time to absorb. B, they are more stable than solid dosage forms. That is false, because liquid dosage forms are good medium for bacterial and fungal growth. So easily microorganisms can attack the preparation. Another problem is hydrolysis. If the drug is in liquid form, it can get easily hydrolyzed. One example is amoxicillin syrup. Now, when you prescribe amoxicillin syrup, you give it as a readily prepared. You prepare in the pharmacy with after adding water to give to the patient. Why the water is not added before? Because the penicillin group drugs can get easily hydrolyzed with water. So you issue the drug, the amoxicillin suspension, for example, in the pharmacy, and after that the expiry is only for maximum 10 days to 2 weeks, depending on the preparation. So then the next part, they are more stable than solid dosage forms. So that is false. So the problems are given by part B, the hydrolysis or bacterial action. The micro action by microorganisms. It may be bacteria or fungi. C, pediatric syrups are allowed to have a maximum of 5% alcohol. So that is false. Pediatric syrups are not included with any alcohol. No pediatric preparations are with alcohol, so that is false. D, they are less susceptible to microbial contamination compared to solid dosage forms. That is what the same question like B. Not less susceptible. Liquid form dosage forms are more susceptible to bacterial action. So microbial contamination is very easy there. They contribute to decrease in compliance in elderly patients. That is false. Elderly patients normally like to take liquid forms than solid drugs. So we'll go to question number 6. True or false about meter dose inhalers. Here it is. Inhalers are used in asthma, mainly in asthma patients. They are administered through the mouth. That is true. They produce more side effects compared to oral preparation from the same drug. That is false because, for example, think about salbutamol. If you take salbutamol, the weight of one tablet is 2 micrograms. So you take 1 or 2 tablets, that is 2 micrograms or 4 micrograms to the body. But when you inhalation, it is only 100 micrograms, 200 micrograms or 400 micrograms. Very little amount. So what you inhale, it will not go to the systemic circulation, blood circulation, as when compared to the oral drugs, very, very little. So B is false. Inhalation give more less side effects. C, coordination between the hand and mouth is known to improve drug delivery. That is true. As a pharmacist, you have to train the patient when you issue this metered dose inhaler. You have to train the patient, the pharmacy, before issuing and demonstrate how to inhale. So, hand to mouth coordination is important because as you expel the drug from the inhaler, immediately at the same time the patient should breathe and hold the breath for 10 seconds. So these instructions you have to give. So coordination between hand and mouth is very important. Beclomethasone inhaler delivers 50 micrograms. That is false. They have 100 micrograms, 200 micrograms, and 400 micrograms preparations. Some propellants are known to damage the ozone layer. That is true. Now they are not used. Some fluorinated allergens are damaging the ozone layer. So go to question number 7. Now, true or false? A, 120 ml of half normal saline has 54 milligram of sodium chloride. Now, what is half normal saline? The normal saline is 0.9% weight by volume sodium chloride solution. Half normal is half of this, 0.45% weight by volume sodium chloride. Now, when the question is 120 ml of half normal saline. So this is half normal saline. This contains 0.45 grams in 100 ml of solution. So 120 ml contain 100 ml contains 0.45 means we will 0.45 grams into 1000 convert to milligrams per gram into 120 ml. So now ml goes with this ml, gram will continue. So it is 0.45 into 120 milligram. $54 milligrams. Answer is I think that is true. This is not false. So question B. The quantity of potassium permanganate required to prepare 200 ml of a 0.025% weight by volume solution in is 500 milligram. Let's see. The potassium permanganate required to prepare 200 ml of a 0.25%. 0.25% weight by volume means 0.25 grams in 100 ml of solution. That means when you convert it to milligrams, 0.45 grams into 1000 milligrams per gram in 100 ml. So this is 250 milligrams in 100 ml. So the amount to prepare is 200 ml. So into 100 ml, it is double of this amount, 500 milligram in 200 ml. So that is true. See 50 ml of hypertonic saline, that is 3%, has 1.5 grams of sodium chloride. So this is also easy. 3% means 3 grams in 100 ml. 3% means 3 grams in 100 ml. So when 100 ml has 3 grams, half of that has the is in the 50 ml. So 50 ml has half of 3, that is 1.5 grams. That is true. C is true. Then a 1.0 ml vial of U100, that is 100 units insulin, has 100 unit of insulin in it. That is true. 1 ml has 100 units in insulin vial. That is, if it is labeled as U100, that means it has 100 units in 1 ml. Opium BP has approximately 20% morphine That is false. Eight. True or false about the following abbreviations. STAT. This STAT means immediately. Give immediately. B. PRN means when necessary. C. Ungentum means ointment, not eye drops. D. AC and PC. AC means before meals, PC means after meals. So this is the question is false. Yeah. The answer given to the question is false. E. QS means quantity coefficient. That is the easy one. We will go to question number 9. Is true or false? pH of a solution is the negative logarithm of the hydrogen ion concentration of that solution. That is true. Minus log of hydrogen ion. pH means minus log of hydrogen ion concentration. pH is minus log of H plus concentration. The bioavailability of a drug is not affected by the pH of the bowel lumen. Lumen means the inside the bowel. That is false because most of the drugs are weak acids or weak bases. They are either weak acids or weak bases. So the drug has to be dissociated weakly. A small amount of dissociated always as ionic form, and most of the drug is in the non-ionic or undissociated form. Then only it is soluble in the fat. That means it can cross the cell lipid bilayer in the cells. The absorption of drugs from GIT depends on ionization of the drug. So the two factors are affected here. pKa of the drug, pKa I will explain in another lesson, and pH of the surrounding medium. So two factors. One is related to the structure of the drug, that is in the structure of the drug. The next part is the pH of the surrounding medium. pH of the surrounding medium. This gives a little bit explanation. Ionized drugs are poorly absorbed than unionized drugs. Ionized drugs cannot, because they have a charge, it cannot go through the lipid bilayer. During absorption, the drug has to pass through the lipid bilayer of cytoplasmic membrane of cells. Then unionized drugs form of drug that is lipid dissolving part is passing through the cells to the body. Right? Ionization depends on the pH. We will come to that. Most drug molecules are either strong acids or strong bases. That is false because most drugs are molecules are either weak acids or weak bases. Here the word they have used is strong. Strong acids, no, they are weak acids or weak bases. Ionization of a drug decreases its entry into the cell membrane. This is what I say. Ionization. If the drug is ionized, more ionization means more difficult. This is non-ionized drug can easily pass through membrane. This is the non-ionized. For example, this is not the exact drug, but COOH part here. So without ionization, it can go through this. See this here, it is ionized. COO minus charge here. So it has an ionic charge. So difficult to pass through. Ionization of a drug decreases its entry through cell membrane. That is true. E buffers resist changes in pH that occur on addition of a large quantity of acid or alkali. We all know that buffers can resist addition of alkali or acid if they add a small quantity. Large quantity means buffer capacity will be over and then it is no more buffer. Small quantities too, not large quantities. Then question number 10. True or false about disinfectants and antiseptics. When hydrogen peroxide BP is prescribed a 3% solution, no, it is 6% hydrogen peroxide. Hydrogen peroxide BP is 6% weight by volume hydrogen peroxide. That is 6 grams of hydrogen peroxide is in 100 ml of the solution. That is hydrogen peroxide BP. Hydrogen peroxide strength is given in volumes also. 10 volume means if you take 1 ml of hydrogen peroxide, that will give 10 ml of oxygen. Hydrogen peroxide release oxygen on dissociation. So after dissociation, 1 ml of hydrogen peroxide will give 10 ml of oxygen. That is equal to 3% hydrogen peroxide. When you calculate the formula, also you can calculate that, find out that. So 3% means 10 volume, 6% means 20 volume. Strength is double. B, the activity of a disinfectant is dependent on the pH of the medium. The activity of a disinfectant is dependent on the pH of the medium. That is true because pH is important in killing bacteria and also keeping the effectiveness of the antiseptic. pH affects the rate of growth of microorganisms. So the antimicrobial agent also, what we use to kill the microorganisms, also change their action depending on their surrounding pH, that is ionization. So potency of the antimicrobial substance depend on the surrounding pH. The absorption of antimicrobial substance at the cell surface. Co-action, the antimicrobial agent should absorb to the bacteria. That also affected by the pH. The optimal pH is 6 to 8, depending on certain the exact pH value depends on the type of activity. C. Anionic surfactants are added to aqueous solution of chlorhexidine to improve detergent properties. Anionic surfactants are added to aqueous solution of chlorhexidine to improve detergent properties. Now, see the wording. Anionic surfactants added to chlorhexidine. Chlorhexidine is a cationic surfactant. That means it has a positive charge. So when you add anionic surfactants, what will happen? It will neutralize plus and minus. So both antibiotic microbial agents will not work. So you can never add together anionic and cationic surfactants. It will not work. So anionic surfactants cannot be added to this cationic surfactant. Chlorhexidine is a cationic surfactant. It has a plus charge. And see, these are cationic surfactants, even normal soap, sodium lauryl sulfate, and all these are anionic surfactants. They have minus charge. See here, minus charge, everywhere minus charge. So they are anionic surfactants. Chlorhexidine is a cationic surfactant, synthetic biguanide, broad spectrum antibacterial and less antifungal activity. B. The optimal concentration of 1% phenol kill spores of microbes in 5 minutes. Calls phenol, also called carbonic acid, oldest anesthetic. This is phenol. It reacts with sodium hydroxide and it forms a salt. So phenol is an acid. Hydrogen. This hydrogen can go away as H plus and it acts as an acid, so it's carbonic acid. Bacteriostatic concentration is 0.1 to 1%. 1 to 2% is fungicidal and bactericidal. 5% solution kills spores in 48 hours. Other part is an additional information. Bacterial activity is enhanced by EDTA and room temperature. It is decreased by alkaline medium. Action is decreased by alkaline medium because this is a positive charge compound. So when it get neutralized with in alkaline solution, it cannot act. Five percent solution is strongly irritating. You can't handle that strength. Normally they use 1 to 2%. Then they use phenol. Okay, thank you very much for your time for reading this. Thank you.